Good morning, everyone. I'll be presenting on biometric authentication, stress in keystroke dynamics. It is co-authored by my professor, Lynette Trevine, and Prof. Henny Kruger. So the basic content that we'll be covering in this session will be the research purpose, the introduction, the methodology that was used, the software that was used to gain the results that were required to make the conclusions, the results, the demographic of the participant group that was used in the experiments, a discussion, and the conclusion. So we'll be discussing the research purpose. The study focuses on the impact or the influence of stress factors on keystroke dynamics as a biometric authentication tool. So that was the purpose of the study. If we go on, the key focus of the behavioral is on behavioral biometrics under varying stress conditions. The stress conditions that were selected for this experiment were a time constraint, a physical constraint, and a knowledge constraint. I'll speak a bit more about the in-depth of the experiment and why these were chosen. A little bit of an introduction. With the acceleration of the digital transformation, protecting both the personal and cybersecurity has become very crucial. Authentication often serves as the first line of defense against unauthorized users and malicious activities, as it presents a method of verifying the identity of users of the system before granting them access to information and other digital resources. Biometric methods like keystroke dynamics provide unique advantages. The main advantages of keystroke dynamics is it's a form of behavioral biometrics. So it's not as intrusive as the physical biometrics that are being used. And it's also a lot cost efficient because when you're gathering or analyzing your keystroke dynamics, it's using hardware and software that everybody uses every day. It's just a keyboard that you use to type on. So it's very cost efficient to actually analyze your keystrokes. But despite these advantages that is offered by the keystroke dynamics, several factors can influence the effectiveness of these types of authentication to an extent that the keystroke authentication techniques becomes unreliable. The methodology that was used was a quantitative research approach because it was gathering data, numerical data, and analyzing it and to draw conclusions from the results. So as I mentioned, the stress factors is a time limit. So when I decided to draw up these experiments, I decided, okay, what affects keystroke dynamics? There's many physical or environmental factors that can influence it. So I thought of in the workplace, what is real world scenarios that I can use to create these experiments? So I thought, a time constraint can simulate time pressure. It can simulate when you have deadlines at work. You get anxious when you have to meet these deadlines and you're behind time and everything. So a time constraint is simulating these types of constraints. Then I used a physical constraint. So this physical constraint represents if you get injured on the job. So you can see over here, it says one-hand typing. So the simulation of this experiment was that the participants had to type with one hand. So it simulates if you broke your arm and then you have to type. And then if you have keystroke dynamics or authentication on your PCs, you might get you might not be able to log in and stuff because your keystroke is vastly different from your norm. And then the last one is a knowledge constraint. So with the digital world and everyone working remotely, we are working a lot with overseas people from foreign languages, from foreign countries that doesn't normally speak your language. So if you're working with data that's in their native language and not yours, you can't really predict what comes. So when you're busy typing, if you need to type a passage or something, you can't predict what comes next as you are as in your native language. You can predict the grammar, you can predict the sentence structure that comes next. But if it's a foreign language, you can't really predict what's coming next because you're not used to, you're not familiar with the grammar of that language, you're not used to the characters that are being used, you might not even know how to create some of those characters on the keyboard. The tool that was used to gather the information from the experiments was ggxlog software. It was originally created at a university in Montreal. There actually was a collaboration between a couple of universities that actually created the software to be able to gather this keystroke data that they used to analyze. Okay. So there's 3 primary metrics of this experiment that were actually recorded from the software. So the first one is words per minute. So a bit more background into what the experiments entailed is the participants had to come in a room, and they were provided with a laptop. They weren't using their own laptop, they were provided a laptop to use, and then they would have to type out a passage. I'll show you an example of an extract of one of the passages in the next slide. So the passages were all different for each 4 experiments because you don't want them to get used to it. You want it to be reliable data that you're using. So they don't get used to it, so they don't type faster in the next one because they know what's coming, what's next. So the 4 different passages you use, and they just had to type out the passage under these 4 different conditions. That's all they needed to do. The software did all the rest. It analyzed all the data itself. I just afterwards looked at it and analyzed the data and made conclusions based on it. So the first one was words per minute. So it recorded the words per minute for each different experiment. If you're wondering, oh, but how can you make conclusions? Of these 3 constraints, there was a baseline. So a baseline experiment was done to just normal typing, normal paragraph. You just, as you go casually, you just type. That served as a baseline, and all these constraints were then compared to the baseline. The second metrics that was used was events per minute. So what is an event per minute? This can be any backspaces, deletions of words, moving it across. It even tracked your mouse movements and everything. So that's what an event per minute. And then the last one is number of appendages. So appendages will also is like highlighting, deleting of a paragraph, deleting of a word, highlighting a word. So it's the number of changes you made to the text while you were busy typing. This is the example paragraph. So this is the English one. So you can even see it's a short paragraph. The experiments were no longer than 5 minutes per paragraph. Also, depending on the typing speed, there was a couple of individuals that took a bit longer to type than was necessary. So this is just the English paragraph, short paragraph, and then the foreign language that was selected was Spanish. So before the experiments, the participated in the experiment, I just made sure that they were unfamiliar with the language, otherwise it wouldn't garner the right results that I needed. So also just a brief participant demographic. We got people from the a working group, so people in industry, we got some people, and then we also took some students as well. You can see it's an even 50-50 split between the work group and the students. And also just for more information, we also divided it by males and females as well. You can see that there's more males than females in the industry, which is normal, so it's a 70-30 split between male and female participants. Just some brief background on just some more information on the software that was used. I already told you that it was a specialized keystroke logging program that was designed specifically for writing of research. So it was specifically designed to garner or gather keystroke analysis. And then it includes free writing styles. So there were 3 different types that you could use for the software, but I decided just free writing because you just want to analyze just the normal typing patterns of the participants. If we move on, now we get into the results. So the results were as you would expect. So you can see this is on experiment, the three different experiments compared to the baseline, grouped by the industry workers and the students. The results show clear deviations in the typing pattern under the stress conditions. So you can see, it's the next one. Typing speed decreases by 43% from when the physical constraint experiment is compared to the baseline. So 43% is different when you're only using one hand. That proves it shows a significant difference in your typing pattern. It's 43%. If we move on to the time constraint, a time constraint actually showed a positive increase. So it decreased the amount of words per minute. It increased the amount of words per minute. So this showed a positive increase, which also shows a deviation. Even though it's positive, it also shows a deviation because it can show that people become more effective or efficient when they're under stress. But it also shows a deviation from the baseline, so it also influences the typing patterns. And then the last one is the typing in the knowledge constraint. So there is a 17%. So you can see, even though it's in a different language, they still get to use both their hands, so it's not as much of a decrease, but it is a significant amount of decrease enough to alter your typing pattern. If we just continue, if we analyze the individual participants as a whole, which provides additional insights into it, and not just per group, so this is per individual participant, you can see that participant 26, wrong button. You can see participant 26, you can see that they actually managed to type faster with their one hand than they did two hands, which is a very, you wouldn't expect that, but alas, one of the experiments actually did type faster with their one hand than they did with their second hand, so it was increased by actually 17.8% was that. So that you will get some results that are like, wow, okay, you didn't expect that. And then, but you can also see the complete opposite hand. You can see that two of the participants, so participant 9 and participant 22, went over 60% deviation from, which is a significant amount. So you can see you can have the normal ones that are about 40%, but then you also get the ones that are way above, which is a significant difference. Moving on to the events per minute, so we can see that it's also based on the working group and the student group. The average number of type events show the same pattern as the words per minute. Because it shows the same, basically it's the same amounts, it's just showing the events per minute, which is the number of characters you type, plus the number of deletions, plus the number of appends, plus the number of movements and everything. So this is just additional information. Except for the time constraints, the experiment resulted in a reduction of the typing events. So you can also see the percentages are almost also similar to the other one. So 43% for the physical constraint. This was a little bit more, so the knowledge constraint for the events per minute was actually a little bit more, from 17 to 29. So you can see that was a bit more of a reduction. And then the time constraint was only a 4.8% increase, apart from the 17% in the original one. But you can see the trends are the same. If we move on to the number of appendages, which is the deletions, changes, everything. The physical constraint influences the typing pattern of participants. Both recorded a significant increase in the number of appendages from the baseline typing behavior. So if you can see it follows the same pattern. It's 38% for the physical constraint, 22% for the knowledge constraint, and a 16% increase for the time constraint. Just based on the males versus females, there wasn't really a significant difference between the two. So you can say, you can just take the groups as is. So if you want to do more in-depth research, you can do more in-depth research for males and females, but this research didn't really show any significant difference between the two demographic groups. Like I said, all three experiments deviated from the baseline experiment, which even though the time was a positive change, it deviates, basically, comes down to it deviates. Okay, a little bit of a discussion. Stress as a factor in keystroke dynamics highlights the impact of certain stress limitations which it has on your typing pattern of the users. All three experiments may cause some degree of stress, which has resulted in deviations from the baseline typing behavior. And some of the following observations were made. So I made this nice table, which shows you all the experiments based on the typing speed, the accuracy, and the efficiency. So based on the results, I drew these conclusions based on accuracy and efficiency. So you can see that even though the time constraint improved, it slightly lowered the accuracy compared to all three. So if you're wondering what this is a summarization of the events per minute, the words per minute, and the number of appendages. So, wrong one. So even though it improved the typing speed, it lowered the accuracy of of your typing pattern, but it also resulted in more efficiency. If you see the knowledge constraint and the physical constraint, it's about the same. It reduced the speed, so it lowered the accuracy, and it was less efficient. In conclusion, the stress alters typing patterns, which is impacting your biometric system. It underscores the need for incorporating stress considerations in system design. So if you're going to implement keystroke dynamics as an authentication tool, you need to take these constraints into consideration when deciding what software to use and how to implement it. So I would not actually implement keystroke dynamics solely as an authentication tool. I would pair it with something else that is a bit more reliable. It addresses the following question: does stress impact keystroke patterns used for biometric authentication? Yes, it does. And depending on the constraint, depending on what degree it affects it, which can be 60%, which is a massive, massive impact. These findings also align with previous research that was done in biometric, such as the work of Lim and the work of Roy on external factors such as physical limitations. Thank you. Any questions?
Thank you very much. Question at the back.
Thank you. That's very interesting. I'm just curious about the experiment and the end result. Did it have to be 100% at the end, or what motivation do you have for checking accuracy by means of deletions? Because I was looking at that foreign language one, and I might type it slightly slower, but I'm not even going to necessarily be able to correct all my mistakes based on that. So I'm just curious how that measure actually measures accuracy and efficiency.
So the accuracy that it measures is the accuracy of your typing once through. So if the amount of deletions is the amount of times you have to correct yourself. So that's what the accuracy implies over here.
So the end result must be 100%?
The end result must be 100%. For future works, you can see the amount of the accuracy of the end product to the original. So that's further investigations can be done on that as well. There's actually quite a few further investigations that can be done on this.
Because I'm not sure that I could ever get to that 100%.
I think we've got another question here.
I may have missed it. Your participants, were they on exactly the same device?
Yes, they were on exactly the same device.
On the same network?
Same
account
manual.
For latency, on the time measures and so forth?
Exactly the same device, yes.
Any other questions? I've got one for you. And when I first read this paper, it sort of was quite interesting because stress as a detector in voice biometrics has been around really since the late 1950s. It's meant to be one of the things that's supposedly safe for voice authentication is you can detect stress. Given what you know, how much data would really be needed to be able to detect stress, duress, etc. with this kind of mechanism?
Well, it depends on the stress that you're talking about, because I just used physical representations. So you can have stress like mental health issues, you can have stress like family issues at home that can influence stress. So this is purely on the physical that I represented the stress as. So, sorry, what was your question again? Because I deviated from that.
How much data does one really need to be able to detect stress of any kind? Is it 8 characters, or my intuition is the more the better?
The more the better.
What would be the sort of the smallest?
The smallest would probably, viable would probably, it's not even that many. So you would probably, like mine was only 30 participants. So for more accuracy, we'll obviously need a bigger data group to do, but as small as 30, you can already see the deviations. But the more the better, because even to do the baseline more times and take an average of it, because you might have been in a mood that day like, oh, I'm just doing this experiment now. It's like, oh, I don't actually feel this for this. So doing the base experiment and finding an average will also benefit, not just taking one setting, one place. So multiple ones will also really help you.
Right, thank you very much.
This is related to the amount of information that you need words or characters to get significant results out of it?
I think it depends on the accuracy of the data you need. So the amount of characters shouldn't really play a part in it because it's just in the end of the day working on that data set that you've done. So if you want more characters, obviously the experiment will be longer because it really took these people 5 minutes, some of them 5 minutes to type that small paragraph. So it depends on the results you want in the end. Or the analysis you want to do, so the number of characters compared to the words per minute compared to that. So it's exactly the data you want to retrieve in the end that will determine actually the number of characters that they will be typing.
All right, one more here. Lots of time for questions.
Yay.
Thank you so much for your presentation. I was just wondering, how did you determine your sample size?
Oh, it was based on availability. So when I did the experiment, it was actually during COVID time or just coming out of COVID time. So people weren't actually really interested in coming to a central place and typing on something that had. So it actually only was determined by the availability, actually. So that would determine the population size.
All right, that brings us to the end of the session. We are a little bit ahead of time, but just a reminder, lunch is at 12:30. And before everybody disappears, can the speakers please pop up for a group photo at the